Question number 65. The plates of a capacitor of capacitance 10 microfarad charged to 60 microcoulomb are joined together by wire of resistance 10 ohm at t equal to 0. Find the charge on the capacitor at t equal to 0, t equal to 30 microsecond, t equal to 120 microsecond, and t equal to 1 milliseconds. So here, this is case of discharging. So formula is Q equal to Q0 e to the power minus t upon RC. Here, when t equal to 0, then Q will be equal to Q0. Q0 is the charge in the beginning, so that is 60 into 10 to the power minus 6 Coulomb. Now, when t equal to 30 microsecond, so we can put the value. Case number B, Q equal to Q0. Q0 is 60 into 10 to the power minus 6 e to the power minus t. T is given as 30 microsecond. So 30 into 10 to the power minus 6 divided by RC. So here R is given as 10 ohm and capacitance is 10 microfarad, 10 into 10 to the power minus 6. So this will become 60 into 10 to the power minus 6 times e to the power minus 0.3. And value of e to the power 0.3 is given as 0.74. So 60 into 0.74 into 10 to the power minus 6. So that will be equal to 44 into 10 to the power minus 6 Coulomb. Now, part C, when t equal to 120 microsecond, so Q equal to Q0, 60 into 10 to the power minus 6, e to the power minus 120 into 10 to the power minus 6 divided by RC, 10 into 10 to the power, 10 into 10 power minus 6. So this will become 60 into 10 to the power minus 6 times e to the power minus 1.2. So value of e to the power minus 1.2 is equal to 0.3. So 60 into 0.3 into 10 to the power minus 6, which is 18 into 10 to the power minus 6 Coulomb. And part D, Q equal to, here t equal to 1 millisecond. So 60 into 10 to the power minus 6 into e to the power 1 into 10 to the power minus 3 divided by 10 into 10 power minus 6. So this will become 60 into 10 to the power minus 6 into e to the power, from here it will become 10, so 3 will cancel out, e to the power minus 10. And if we evaluate it, so it will become 60 into 10 to the power minus 6 into 10 to the power minus 5. So value of this. So this will come out to be value of e to the power minus 10 is into 5. 5 into 10 power minus 5. So this will become 0.003 into 10 to the power minus 6 Coulomb or 0.003 microcoulomb. So that is our answer. Now, in question, generally in competition, the value of E power e to the power, like here we came across 0.3, etc. So it will be provided. So nothing to worry. 0.74 times. So now let's go to next question. Question number 66. Here, a capacitor of capacitance 8 microfarad is connected to a battery of even 6 volt through a resistance of 24 ohm. Find the current in the circuit just after the connections are made, one time constant after the connections are made. So here, when connection is made, at that time, the capacitor will be have like short circuit. So current in that case will be just value of potential difference, that is 6 RPM by 24, and that is equal to 0.25 ampere. Now, after one time constant, so time constant, so T equal to RC. We can evaluate. R is given as 24 into C is 8 into 10 to the power minus 6. So we can put the value. This is T of charging. So Q equal to Q0 1 minus e to the power minus T upon RC. So we put the values. Q0 is CV, so that is 8 into 10 to the power minus 6 into voltage 6 times 1 minus e to the power minus. Here, it is not necessary to evaluate this because T is given one time constant. It means T is also RC. So we will be left with e power minus 1. And if we evaluate, so 1 minus e power minus 1 will be equal to 0.63. So 8 into 6 into 10 to the power minus 6 into 0.63. So this will come out to be 3.024 into 10 to the power minus 5 coulomb. Now, further, we have to find out the current. So for that purpose, here we apply Q equal to CB. We can get the voltage. So voltage Q equal to 3.024 into 10 to the power minus 5 equal to C is given as 8 microfarad, that's 8 into 10 to the power minus 6 into voltage. So we evaluate this voltage, so V will be equal to 3.024 into 10 to the power minus 5 divided by 8 into 10 to the power minus 6. So that will come out to be 3.78 volt. Now we can apply the formula E equal to V plus IR. So here we put E as voltage or EMF of battery, that is 6, and the V is 3.78 plus I times resistance. Resistance is 24. So here our concern is to get I. So 6 minus 3.78 divided by 24. So if we evaluate it, we will get 0.0925 ampere. Now let's go to the next question. Question number 67. A parallel plate capacitor of plate area 50 centimeters square and separation between the plates is 0.1 millimeter is connected to a battery of 2 volt through a 16 ohm resistor. Find electric field in the capacitor 10 nanosecond after the connections are made. So here, first of all, we have to evaluate the capacitance C equal to epsilon naught A upon D. 8.85 into 10 to the power minus 12 into plate area 50 into 10 to the power minus 4 divided by plate separation 0.1 into 10 to the power minus 3. So this will give 35.4 into 10 to the power minus 11 farad. Now, we know Q equal to Q0 in case of charging, 1 minus e to the power minus t upon RC. And we know that E is given by 2 upon epsilon naught A. So our concern is to find electric field from Q. So in place of Q0, we can write E times epsilon naught A. So this relation will become E equal to E0 times 1 minus e to the power minus t upon RC. So E equal to Q0 upon epsilon naught A. We write here Q0 upon epsilon naught A. Here, if question arises how we have got it, so it is very simple. Divide each term by epsilon naught A, and then this will become E, and this will become E0 because there is Q0. So times 1 minus e to the power minus t upon RC. Now, Q equal to CV. So here we can write C times V0 means initial voltage or potential difference divided by epsilon naught A times 1 minus e to the power minus t upon RC. So we put the values. So this is equal to C is, we have just got 35.4 into 10 to the power minus 11 divided by 8.85 into 10 to the power minus 12 times plate area, that is 40 into 10 to the power minus 2. This is C into V0, initial voltage. So this is 2 volt battery. So 2 times 1 minus e to the power minus t. Time is given 10 nanoseconds. So 10 into 10 to the power minus 9 divided by RC. So R is given as 16 ohm and capacitance we have found as 35.4 into 10 to the power minus 11. So if we simplify this, so this will become e to the power minus 1.76. And the value of this is equal to 0.172. So bracketed term will become 1 minus 0.172. So that will be 0.83. So let's write it here. So E will be equal to, let's write it again, 35.4 into 2 into 10 to the power minus 11 divided by 8.85 into 40 into 10 to the power, here area is 40 into 10 power minus 4. By mistake I have written it. So 40 into 10 to the power minus 4, and inside the bracket, as I told you, it will become 0.83. Now, after evaluation, here 10 to the power minus 12 is missing because 8.85 into 10 power minus 12 is the value of epsilon naught. So this will become 0.2 into this value, 35.4 into 2 divided by 8.85 into 40, and this power will become minus 11 plus 4 plus 12. So that will give 10 to the power 5, and division of these two. 35.4 into 2 divided by 8.85 into 50 will give 0.2 into 10 to the power 5 into 0.83. So this will become 0.166 into 10 to the power 5. Since this is electric field, unit will be volt per meter. And that is our answer. Thank you for watching.